Hi guys, this is Dr. G here, and in this video we are going to talk about concentration of a solution. And the learning objectives of this uh, video is actually to understand what is the concentration, and then we will learn how to calculate the concentration of a solute in a solution, and also we will use the concentration units to calculate the amount of solute or solution. All right, so let's first talk about the term concentration. Okay, so basically, in general terms, concentration stands for the amount of solute that you have in an amount of solution. Okay, so the concentration of a solution is expressed as the amount of solute divided by the amount of solution. Okay, so depending on the unit that you use to measure the amount of solute and the amount of solution, okay, you might have different uh, units for concentration. Okay, uh, some of the common terms in especially areas of chemistry such as polymer chemistry and health science is mass to mass percent, and then volume to volume percent can also be used, especially in pharmaceutical industry. And sometimes we also use mass to volume percent. But of course, as chemistry people, the most important concentration term is going to be molarity. Okay, molarity. Why that term is important? Because it talks about moles of solute with respect to the amount of solution in liters. Okay, so all four of these terms are used in nature. Okay, but the most common one is the molarity. Okay, molarity. So we will talk about each of these terms in more detail, but of course we will spend much more time on molarity. All right, so first let's talk about mass percent. Okay, mass percent. So as the name implies, okay, in mass percent, okay, in mass percent, concentration is defined as the grams of solute you have in grams of solution that you have. But here's the thing. Here's where most people get confused. Okay, so remember, in concentration, okay, in concentration, the bottom term is always the amount of solution. Okay, amount of solution. So solution has two components. Solution has two components. Okay, you have a solvent and then you have solutes, one or more. You can have solutes. Okay, so when you are considering the amount of solution, okay, make sure that you have to add both solvents and solutes. That is where most people make mistakes. Okay, that is where most people make mistakes. Okay, so amount of solution has both solutes and solvent, and then of course you multiply it by 100% because mass percent is a percentage. Okay, uh, there is also a different way of you know understanding this same equation. Okay, mass percent could also be defined as grams of solute per 100 grams of solution. Okay, both of them are correct, but most common equation is the top one. So let's talk about a simple example. Okay, so in here you are making a solution of potassium chloride. You are making a solution of potassium chloride by having 8 grams of KCl. Okay, first you measure 8 grams of KCl, and then you fill the beaker with water until the total mass has a 50 grams has 50 grams. Okay, so basically, if you want to calculate the mass to mass percent, you first have to know the solute. Solute is KCl, and then you have 8 grams of it. You have 8 grams of solute. And then the amount of solution is 50 grams, or in other words, it's 8 plus 42. 8 is the amount of grams you have for solutes, and then 42 is the solvent mass. Okay, so, or in other words, it is total mass of 50, and multiply it by 100%. Multiply it by 100%, and grams to grams will cancel out, and then you will have 8 divided by 50 multiplied by 100. So the answer is 16 16%. So that is how you calculate the mass percent. That is how you calculate the mass percent. All right. So in this slide, I have given you the detailed explanation for everything, okay? But I'm pretty sure you understand how I got the 8 grams, because you measured 8 grams of KCl, and then you add water until it becomes 50, which means you have 42 grams of water, okay? But when you plug the numbers, you will get 16% as your answer. All right, so here is a stepwise method to calculate these concentrations, especially in mass to mass percent. So you can pause the video and see if you understand it. But I mean, I'm pretty sure if you handle the question or the calculation that we did, you should be able to easily understand this. All right, let's try this study check. You might want to pause the video and then see if you could do this without my help. All right, in this study check, you have a solution that is prepared by mixing 15 grams of sodium carbonate, okay, and 235 grams of water. Okay, calculate the mass percent. Calculate the mass percent. What you need to do is you have to calculate the mass percent. To do that, you need to have the amount of solute, which is basically 15.0 grams. 15.0 grams. And then you need the amount of solution, which is 15.0 grams plus 235 grams, and of course multiply the whole thing by 100%. Okay, so which is basically 15.0 divided by 250. Grams to grams will cancel out, multiply it by 100. You will get the answer. And in here, the correct answer is 6%. Correct answer is 6%, which is C. Okay, so in the next couple of slides, I will have a detailed explanation of this calculation. So if you want, you might want to pause the video and then review that calculation one more time, okay? All right. So similar to mass percent, you can do volume percent calculations. Only difference is that in here, the solvent and the solutes are measured in milliliters or volume terms, okay? That is the only difference. So basically, on top you have the amount of solute. At the bottom of the equation, in the denominator, you have the amount of solution that you have, and you multiply the whole thing by 100%. All right, similar to that, you can also get an equation for mass to volume percent. In this concentration term, your solutes are in grams, and your solution is in milliliters. Okay, solution is in milliliters. All right, so let's see if you could do this study check. Okay, you might want to pause the video now and then see if you could do this one. Okay, see if you could do this one. All right, in here, write 2 conversion factors for each solution. I want you to write conversion factors for each solution. So you have 8.50% mass to mass sodium hydroxide. You have 8.50% mass to mass sodium hydroxide, which means it could be that you have 8.50 grams of sodium hydroxide in 100 grams of solution. Okay, 8.50 grams of sodium hydroxide in 100 grams of solution. So here is the answer. Okay, so you can write the conversion factor as 8.50 grams of sodium hydroxide in 100 grams of solution. In the question number B, 5.75% volume to volume methanol means you have 5.75 milliliters of ethanol in 100 milliliters of solution. 4.8% mass to volume HCl means you have 4.8 grams of HCl in 100 milliliters of solution. So that is how you understand these concentration terms. But let's jump into the most important concentration term, which is called molarity. Once again, this will be the focus of your exams and assignments. So I highly recommend that you understand the molarity term in much more detail. Okay, so let's talk about molarity. Okay, molarity is defined as the moles of solute per volume of solution, per uh, liter of solution, I would say. Okay, liter of solution. So how many moles of solute you have in 1 liter of solution is known as molarity. Okay, the number of moles you have in 1 liter of solution. So in here you can define an equation for molarity. Let's call it M. Okay, I actually prefer to use C. Okay, so let's call molarity as C. Okay, from here onwards I'm going to use C because I mean in previous equations we used M a lot of times. So sorry about the confusion, guys. So let's call molarity C. So C equals N divided by V. I want you to write this equation down somewhere. I want you to memorize it. If you know this equation, you are going to be fine in the exam. Okay, let's define the terms. C is once again molarity. So what is N? N is the number of moles. Okay, and then what is V? V is volume in liters. This is important, guys. Okay, it is not milliliters, not cubic centimeters, it is liters and liters only. Okay, so always remember to substitute the volume in liters. That is the most common mistake that most people use. They use whatever the volume units that we give in the exam, but never do that. Okay, always remember to use liters. Always remember to use liters as the unit. Okay, so remember this equation will come in handy in the future. Okay, C equals N divided by V. C equals N divided by V. So basically 1 molar. Okay, oh, molarity I mean, let's talk about the units for molarity. Okay, units for molarity. So it is moles divided by liters, so it is MOL divided by L. Okay, so this is the units for molarity. Or I mean, you can say it is MOL space and then L minus 1, okay, per liter. Okay, you can write it like this. Or sometimes 1 liter. Okay, the other important thing is like 1 liter equals 1 decimeter. You know that, right? 1 liter equals 1 decimeter cube. Okay, 1 decimeter cubed. So molarity can be defined as moles per decimeter cubed. Okay, this is also a valuable unit. Mostly in Europe and Asia they use moles per decimeter cube. Okay, so this is the most common term if you are reading European journals, or if you are working in Asia, this will be the more common term. So don't get spooked when you see this. Okay, that is the most important thing. Don't get spooked. Oh, excuse me. All right, so you know the terms now, you know the units, right? So it is either moles per liter or moles per decimeter cubed. All right, so I mean, sometimes rather than calling it moles per liter, okay, you can use an uppercase M. Okay, uppercase M means moles per liter. Okay, uppercase M means moles per liter. So this uppercase M means moles per liter in this calculation. Okay, 1.0 M solution of sodium chloride is defined as 1 mole of sodium chloride is present in 1 liter of solvent. Okay, this is how you define it. 1 mole of sodium chloride is present in 1 liter of solution. Let's do a simple calculation. Okay, of course the answer is explained in the next couple of slides, but I don't want you to go through it. Okay, I want you to learn these calculations by heart. Okay, so let's read this. What is the molarity of half a liter of sodium hydroxide solution, okay, if it contains 6 grams of sodium hydroxide? If it contains 6 grams of sodium hydroxide. So let's take a notebook or notepad and then try to do this. Okay, so let's write down the terms that you have half a liter. Okay, you have sodium hydroxide. That is important. First of all, you have sodium hydroxide. have sodium hydroxide. So everything that you do is to sodium hydroxide, and you have half a liter of sodium hydroxide solution, and it contains 6 grams. That is also important information. It contains 6 grams. So they want us to calculate the molarity. Okay, they want us to calculate the molarity. All right, so let's maximize it and then do this. So these are the units that you need to know. Okay, the volume, okay, we know the V and we know the mass. They want us to calculate the molarity. Let's call it C. Okay, so these are the terms. All right, guys, so you know, to calculate molarity C, you need two things: number of moles divided by volume. Okay, this is the equation. Remember this equation. This is important. If you know this equation, you can get a PhD with a 4.0 GPA. Okay, so remember the equation. C equals N divided by V. Okay, so here's the thing. Do we know V? We know V. V is given, which is 0.5 liters. Do we know N? No, that is not given. N is not given. So here's the problem. So N is not given. Okay, so we have to calculate N, right? So V is half a liter, but N is not given. But I have taught you an equation before for the number of moles and mass. Okay, so number of moles is equal to mass divided by molar mass. Do you remember that equation? Yes, you do, right? So we know M, mass is given, right? So if you want to calculate the number of moles of sodium hydroxide, you use the mass of sodium hydroxide, which is given, and then you divide it by the molar mass of sodium hydroxide. Okay, so N, number of moles of sodium hydroxide, equals mass of sodium hydroxide is 6.00 grams. Molar mass is 40. Let's call it 40.0 grams per mole. How did I get 40? Sodium is approximately 23.0, oxygen is 16.0, and then hydrogen is 1.00. So you add all these up, you get 40. Okay, so grams to grams will cancel out and you get the moles. Don't do the calculations or try to use a calculator every step. So just keep it as is, 6.00 divided by 40.0 moles. Okay, so you know the number of moles now. So plug them in. Okay, so we want to calculate molarity of the sodium hydroxide solution. We already know the moles, which is 6.00 divided by 40.0 moles, and then you divide it by volume, which is 0.5 liters, So when you do this calculation, you will get the concentration. Okay, you will get the concentration. So the concentration here is, if you do the calculation correctly, it will be in moles per liter. Of course, it will be in moles per liter, and it will be 0.30 moles per liter, or you can write it as 0.300 m. That is it, guys. Very easy. All you need to know is to remember two equations. What are the two equations that you need to know? C equals N divided by V. Of course, sometimes N is not given. So to find out N, okay, to figure out N, you have to use the equation where N is equal to mass divided by molar mass. Use these two equations and you can easily do these molarity calculations. Okay, so we will do plenty of calculations in this video so that you should be able to understand it very easily. Okay, all right, so let's go to the lecture note. in here there is a stepwise analysis for the calculation, so if you have time, please feel free to pause the video and try understand this calculation. But if you followed the method that I did, you are more than fine in the exam. Okay, All right, here's another question for you. Okay, here's another question for you. Let's see if you could do this one. Okay, you might want to try it by yourself. Okay, you might want to try it by yourself. So pause the video and try it. Okay, guys, so this is what we have. We have a potassium nitrate solution. Let's use black. Okay, we have a potassium nitrate solution. Awesome. So for that you use 34.8 grams of potassium nitrate. Okay, and the other important thing is the molarity is given. Okay, or molarity is not given. That is what you need to find. And then oh, excuse me, sorry about that. And you have given the volume, which is 0.225 liters. Okay, volume is given, so you need to find the molarity. You need to find the molarity. Let's call it C. Okay, so here's the thing. To find molarity, you need the number of moles divided by volume. Volume is known, of course. The number of moles is not known. N is not known. Because N is not known, we will use N equals M over M equation. Okay, to figure out the number of moles. Okay, so mass here is 34.8 grams. Okay, and the molar mass, that is molar mass of potassium nitrate. So to do that, you will use a periodic table at the atomic mass for potassium, and then at the atomic mass for nitrogen, and at the atomic mass for 3 oxygens. Okay, so if you add all of them up, it will be around 101.1. Okay, so 101.1 grams per mole. Okay, grams per mole. So grams to grams will cancel out. And your answer will be in moles. Okay, answer will be in moles. Don't punch the numbers in your calculator. Okay, just keep them as is. Do the calculation at the end. Okay, so this is the number of moles you have. Okay, once you have the number of moles, you can switch to the other equation. So let's find the molarity. Number of moles is 34.8 divided by 101.1 moles multiplied by volume. Volume is how much? 0.2 something, right? Yeah, 0.225 liters. The most important thing is that volume is given in liters. That is extremely important. Okay, that is like extremely important. Well done. All right, so let's punch the numbers in the keyboard and then in your calculator and see if you could get the answer. Okay, so let me do this. So your answer will be approximately 0.344 moles per liter. Here is your molarity. So let's go back to the equation. Where's the equation? Okay, so the answer is A. The correct answer is A. And of course, here is the detailed stepwise answer breakdown. Okay, so if you want, you can pause the video and then see if you could understand it. I'm sorry, I think I made a mistake. Okay, so molarity is 1.53. I think I punched the numbers incorrectly, but if you punch the numbers correctly, you will get the molarity as 1.53. The 0.33, I think I forgot to divide the terms by divide the volume by divide the number of moles by by volume. Okay, so number of moles is 0.344, but the concentration is actually once you divide that by 0.225, which is 1.53. Okay, 1.53. So the answer is B actually. Okay, my mistake. All right, so that is your answer. Okay. All right. So in the next few slides, I'm giving you a few of you who wants to depend on conversions factors and not on equations. If you prefer conversion factors and not equations, you may want to go through these slides. Okay, so you can pause the video and take a look at it. But if you remember the equation C equals N divided by V, you don't have to memorize these conversion factors. Okay. All right, so here's the guideline if you're planning on using the conversion factor, but I don't recommend it. So I have a few more study checks so that you can practice your skills in doing concentration calculations. Okay, so I mean I have used in here I have used a sodium hydroxide solution where you have 75 grams of sodium hydroxide solution and the concentration is 14%. Okay, see if you could figure this one out. I'm not going to spend too much time on these calculations. They are very straightforward. Okay, you only have to know is that you're figuring out the amount of, let's call it X grams, how much sodium hydroxide you need to make 75.0 grams of solution, and then you multiply it by 100%. Okay, and what you have is 14%. Okay, so if you do the calculation correctly, okay, or if you plug the numbers in your computer correctly, the answer will be 10.5 grams. Okay, the answer will be 10.5 grams. So X will be 10.5 grams. So here's the detailed calculation if you want to pause and take a look at it. Okay, and here is another volume to volume calculation. Once again, these type of calculations are not that interesting in chemistry, but I mean you have to know them, of course. Okay, so in here, so you want to know what is the volume in ethanol. Okay, if you have a, oh, actually they're not asking for the volume, so your volume to volume percentage is 5.75%, and then you used 2.25 milliliters. Oh, they're asking for the volume, the final volume. Okay, they're asking for the final volume. Okay, so if you plug the numbers correctly, okay, you will get answer C as the correct answer. Okay, once again, here is the breakdown of the solution. You might want to take a look at it. All right, so this is important. This is a molarity calculation, so let's do this one together. Okay, how many grams of aluminum chloride are needed to prepare 120 milliliters of 0.150 molar solution? So let's use our equation. C equals N divided by V. Okay, so I'm sorry, I made a mistake. It is not M, it is N. C equals N divided by V. Okay, so we need to figure out N first because they're asking for the grams. So to calculate grams, you need to have the number of moles. So we have to figure out N, which is basically CV. Okay, concentration is given, or the molarity is given, which is 150 moles per liter. And then the volume is given, which is 125 milliliters. We don't need milliliters. Convert it into liters. How do you convert milliliters to liters? Divided by 1000. Okay, so it is 0.125 liters. You will see that liters to liters are going to cancel out, and you will have the number of moles. You will have the number of moles here. Okay, you will have the number of moles here, And then once you have the number of moles, okay, let's not use a calculator, let's just write them down. 50 moles, okay, multiplied by 0.125. so this is the number of moles. To get the mass, you take the number of moles and you will multiply it by the molar mass. Okay, so 0.150 times 0.125 moles multiplied by molar mass of aluminium chloride, which is around 133.3 grams per mole. Moles to moles will cancel out and your answer will be in grams. And if you plug, let me do the calculation really quickly. So if you plug the numbers correctly, it will be 2.5 grams, okay? Which is the answer C. Alright guys, so here is the answer in more detail. Okay, here is the answer in more detail. But of course, you don't need all these details if you understand the two equations, okay? If you understand the two equations. I mean, I think that is all the study checks that I have for concentration or molarity. But I feel like we should do a little bit more. Yeah, let's do a simple calculation really quickly, okay? Okay. Let's say you are making a nice solution of, let's say, potassium nitrate. Okay, you are making a nice solution of potassium nitrate. Okay, you are making a nice solution of potassium nitrate. To make this solution, you are using, let's say, 20.0 grams of potassium nitrate. Okay, and then the final volume of your potassium nitrate solution is, let's say, 125. Let's use a better number than 125. Let's use 100 milliliters of potassium nitrate. Okay, so you might want to calculate the molarity. See if you could do this one just for practicing purposes. See if you could do this one really quickly. Let's see if you could do this calculation really quickly. So you might want to pause the video now and then try it. Okay, so let's get to it. First of all, you need to find the molarity, which means C. To do that, you need two things. You need the number of moles of potassium nitrate divided by the volume of potassium nitrate in liters, of course. You know the volumes, or you're good, but you don't know the number of moles. So the first thing that you need to do is to calculate the number of moles of KNO3. Find KNO3, potassium nitrate. Okay, awesome. To do that, you use the mass, which is 20 grams. And then the molar mass, I think the molar mass is around, I don't even remember. So you add all of it. So I think 101. Okay, 101.0.1. Okay, doesn't really matter for significant figures. All right, so grams to grams will cancel out. And your answer will be, I don't know. You will use a calculator and then figure it out. Okay. Okay, this is the number of moles. Once you know that, you can figure out the concentration, which is basically 20.0101 moles. This is the number of moles divided by the volume, which is 1 over 0.100. Okay, this is the volume in liters. Okay, so your answer will be in moles per liter. Your answer will be in moles per liter. All right, so do the calculation and figure out the answer. All right, so very rhetorical, right? So practice the two equations, you will be more than fine in the exam, Now let's talk about dilutions. This is one fancy calculation, to be honest, okay? So in a dilution, okay, what you do is you take a high concentration solution, okay, and then you add a certain amount of that high concentration solution into a different glassware, let's say, and add some water. When you're adding more water, you're adding solvent. If you're adding solvent, you are decreasing the concentration, right? That is how you do a dilution. So in a dilution, you usually add water or more solvent and then reduce the concentration. That is what you call dilution. So in this part of the lesson, we are going to talk about doing calculations related to dilution, especially if you are a health science student or a nursing student. Okay, you might want to learn these dilutions well, because when you are calculating the dosages of the injections or medicines that you are going to give to your patients, you might want to know these calculations like the back of your hand. Otherwise, you are going to get sued, right? All right, guys. So let's do this. So in a dilution, you are adding water or you are adding more solvent, okay? And basically, when you're adding more solvent, the volume is increased. So that means the concentration is decreased. Some people are like, why is that? You just learned, right? The concentration or molarity is inversely proportional to volume. Okay, so if you increase one, the other decreases. Okay, if you increase volume, the concentration decreases. That is how the inverse proportionality work, right? All right. But here's the thing, the number of moles or the mass of your solute, they remain the same, okay? You don't do anything to it. Here's a nice way of doing these calculations, okay? If you want to do dilution calculations, you might want to remember another equation, okay? Which is called C1V1 equals C2V2. Otherwise, you will be doing the calculation in a very long manner, okay? So remember this equation, C1V1 equals C2V2. This is the equation that you will apply when you are doing dilution calculations. But let's define the terms, okay? So what is CV? What is the multiplication of CV gives you? It gives you the number of moles. Right? So this CV product, okay, the product of concentration and volume, gives you the number of moles. So basically in these dilutions, the thing that does not change is the number of moles. You are changing the volume so that you are changing the concentration, but the only thing that is not changing is the number of moles. So basically, initial number of moles is going to be equal to the final number of moles. That is why we came up with this equation, okay? The multiplication of concentration and volume basically gives you the number of moles. So C1V1 equals C2V2, initial and diluted. Okay, so most of the times it could be initial or transferred. Okay, transferred. So usually in chemistry, we usually have a stock solution, high concentration solution. From that, we are transferring a small amount and then we dilute that small amount into a larger volume, right? So V1 is usually the initial volume, or most of the times it is the transferred volume. Okay, it is the transferred volume. And then V2 is the final volume, C2 is the final concentration or molarity, and C1 is the initial molarity. Okay, so let's do a couple of calculations. These are very easy to handle, okay, especially if you know the equation. All right, so once again, in a dilution, you keep the number of moles the same, but you increase the volume, so therefore the concentration is decreased. Okay, so there is a stepwise guideline to do these calculations, but most people wouldn't need it if you know the equation, and I never even look at these stepwise things, especially since I know the equation. Okay, so let's do this calculation and try to understand it. Okay, so in this calculation, I'm asking you, what is the final concentration when half a liter of 6.0 moles per liter HCl solution is diluted to a final volume of 1 liter? Final volume of 1 liter. Alright, let's do this, guys. Let's do this. First of all, you want to summarize what you know and what you need to know. Okay? What you know and what you need to know. That is the important thing. Okay? What you have, let's say here is our beaker. Pardon my poor drawings. Okay? Here's my beaker. And in here I have an HCl solution. I have an HCl solution, of course. And in this HCl solution, the terms that I know is that I have half a liter. And then the molarity is 6.0. We know that. And then what you do is you double the volume. Okay, so you are taking the 0.5 liters and you make it doubled. Okay, you increase the volume to 1 liter, so concentration should be half of that, right? So it should be 3 moles per liter. But I mean, let's say your brain is slow or you don't want to think it like that. You want to use an equation, right? Okay, so the final volume is what? The final volume is 1 liter. And they're asking us what is C2, final concentration. So let's do this. So to that, we are using C1V1 equals C2V2. Okay, C1 is 0.5. Oh, that is actually V1. C1 is 6.0 moles per liter. V1 is 0.5 liters. Okay, and then Z2 is unknown to everyone, but the final volume is 1.0 liters. So liters to liters cancel out. That is important to know. If the units cancel out for volume, that means you can use either liters or milliliters. It doesn't really matter as long as you are using the same unit. Okay, as long as you are using the same unit, it doesn't really matter. Okay, so liters to liters will cancel out. Oh, I made a mess anyway. Okay, so C2 will be what? 3.0 moles per liter. Moles per liter. Okay, an easy calculation. But I mean, hey, this is way too easy, so let's do something a little bit more difficult. Okay, so let's say you have a stock solution of sodium hydroxide. Okay, so you have a sodium hydroxide solution, and the concentration of the sodium hydroxide solution is, let's say, 1.0 moles per liter is the stock solution. What you do is you take a small amount. You take, let's say, 20 milliliters. Okay, and you put it in a different glassware. So here's the 20 milliliters. Okay, here's your 20 milliliters, and you put it in a different glassware, and then you make it up to, let's say, 100. Okay, so final volume is 100 milliliters. You transfer 20 milliliters into 100 milliliters. You transfer 20 milliliters into 100 milliliters. Figure out C2. Okay, let's do this. So the equation that you need is C1V1 equals C2V2. Let me make this a little bit more confusing. Okay, so in the beginning you also had 100 milliliters. So what you had was a sodium hydroxide solution. You had 100 milliliters of it, and the molarity is 1.0 moles per liter. And from that, you are transferring 20 milliliters into another beaker, and then you are increasing the volume to 100 milliliters. What will be the final concentration? So you need to find Z2. You know the final volume, which is 100 milliliters. Awesome. So you transferred 20 milliliters. Don't use the 100 milliliters because you had 100 milliliters. It doesn't matter whether you had a gallon, okay? You are only using 20 milliliters. And the C1 is 1.0. Okay, so milliliters to milliliters will cancel out. This to this will cancel out. And then you will basically have a 5 times dilution. So when you plug the numbers, what you have is C2 is 0.20 moles per liter. Alright, so how did I do this? I mean, I didn't even plug I didn't even do any calculations, but of course you divide it by 100, so it will be 0.2. Or in other words, you are increasing the volume by 5 times. You are increasing the volume by 5 times. How do you know? You get 20 and then you make it 100. So if you divide 100 by 20, that is a 5 times dilution. So if you are diluting it 5 times, then your concentration should decrease by 5 times. So 1 should be divided by 5, so it will be 0.2. All right, so that is how you do it. And there is a couple more calculations in your video. Okay, so you might want to do them, okay, for clarity, but that is all there is to know. Okay, that is all there is to know. So here's the study checks. You can you can pause the video and try them. I'm not going to do them in the video, but you can try them so that you can hone your skills. Okay, here's the second one, and here's the third one. Okay, in this third one, it is more interesting to me because it uses molarity. Okay, so whenever there is molarity, I like it because that is the most common concentration term. So what you do is you are increasing the volume of 0.6 molar HNO3 by 3 times. You had 0.180 liters, you make it to 0.540 liters, so you are diluting it 3 times. So the concentration should decrease by 3 times. So the final concentration should be 0.6 divided by 3, which is 0.2. Is 0.2. There we go, 0.2. Okay, so with that, I'm going to wrap up this video. Let me know if you guys have any questions or comments. You guys have a nice rest of the day. Okay, have a good one, guys.